Hi, my name is Augustin Popa, and I'm a product manager on the Microsoft C++ team working on vcpkg. vcpkg is a free and open source C and C++ package manager. It is designed with simplicity in mind, solving many common problems that come up when managing library dependencies. Some of these problems are intrinsic to these programming languages and require a more creative solution than you perhaps may be used to with package managers for other languages. In this video, I will give an overview of vcpkg and how it can support you as a developer in just under 10 minutes. Whether you are a student, hobbyist developer, or professional in the industry, I hope you will find this tool helpful for your C and C++ development. vcpkg is supported on Windows, macOS, and Linux, and can run on your local machine or your preferred continuous integration environment. You can also use it with your preferred compiler or build system, as vcpkg is designed to be as flexible as possible. It also builds packages from source, meaning you can choose your preferred build configuration, including platform, architecture, and compiler flags, so that it matches your development environment. In C and C++, this is important because a project cannot depend on a library that is compiled in a different way. With that said, you can absolutely download pre-built libraries using the binary caching feature. This feature allows you to point to a package feed like GitHub Packages, Azure Artifacts, or a NuGet feed HTTP provider or other cloud storage provider that allows you to upload and store binaries and other files. Once this link is active, vcpkg will automatically cache libraries and it builds and subsequently download them from the cache when someone else on your team or your continuous integration system needs a new copy. In other words, you only need to build from source once, then cache the output for reuse later. vcpkg will verify if something has changed in your build configuration and do a fresh build only if necessary. In vcpkg, a port is a build recipe that produces a package. A port has a version number for the corresponding package it produces, as well as a port version that is used when you want to make changes to the build recipe itself. vcpkg also has triplets. A triplet captures the target build environment, such as the CPU, OS, compiler, and runtime, in a single convenient name. vcpkg provides over 70 default triplets that you can build with, but you can also define your own. To install a package on your system, vcpkg runs a port file, which is a CMake script. The script typically contains steps to download source code or run a build, but can do a lot more as it is highly customizable. vcpkg comes with a massive open source library registry that is actively maintained by the C and C++ community. You can download over 2,000 unique, customizable, and publicly available C and C++ libraries. You can choose which versions or features of these libraries you wish to install, and as stated earlier, vcpkg can produce a custom build based on your desired build configuration. vcpkg will automatically install any transitive dependencies, that is, dependencies of dependencies, without you having to list every single one out. Furthermore, the vcpkg open source registry is thoroughly tested by a continuous integration process. The C and C++ library ecosystem is very fragmented and diverse. Many libraries depend on each other, and sometimes they disagree about things like what version of another library they want. vcpkg resolves all of this in the open source registry. The registry is a Git repo, and at any point in time in the history of that repo acts as a baseline, tracking a set of libraries that are each set to a particular version. Whatever baseline you choose to follow, you can download the libraries of your choosing without having to manually resolve version conflicts yourself. There are two ways to install libraries using vcpkg. Classic mode allows you to run console commands specifying which libraries you want. These libraries are then installed under the vcpkg installation directory. This is an easy way to get started with vcpkg if you're just looking to get up and running fast. However, for most users, we recommend manifest mode. In this mode, vcpkg takes a manifest file called vcpkg.json as input and builds packages in a subfolder of your actual project. The manifest file can list your library dependencies, library features, version constraints, and other relevant input. Since this is a basic text file, you can check it into your source control repository so your whole team can make use of it. Furthermore, it is very useful for achieving reproducible builds. vcpkg will strictly follow the instructions in the manifest file and will never change the libraries, versions, or features it installs afterward. If you want to make a change to your dependencies in the future, you must edit the manifest file accordingly to give vcpkg new instructions. vcpkg versions packages differently than most package managers. As I mentioned earlier, you can list out your desired packages and point to a baseline, which provides you with a reasonable set of default package versions. but you can also define a minimum version constraint or an override. A minimum version constraint lets you set a particular package to a version greater than the baseline. There is no such thing as a maximum version constraint in vcpkg, as it will always choose the minimum one that agrees with your manifest file. If you set a minimum version constraint, it will only attempt to download a higher version if vcpkg detects that the minimum version won't build successfully with your other dependencies. But given a particular manifest file as input, vcpkg will always build the exact same set of dependencies every time, whether you do it today or 5 years in the future. Lastly, vcpkg supports overrides. Overrides let you ignore vcpkg's normal version resolution and opt for a more traditional package management experience where you can pick and choose exactly which versions of a package you want to install. However, this does leave it up to you to resolve any version conflicts that may arise. We recommend using overrides only when absolutely necessary. I mentioned earlier that vcpkg comes with a large open source registry of libraries, but you can also define your own custom registries for other libraries. This works fundamentally the same way as the open source registry. For instance, you can set up a registry as a Git repo and take advantage of the versioning and manifest features that vcpkg provides. A registry can also be configured as a basic file system. A common application of registries popular with professional teams is to fork the open source registry so you have your own private copy. This lets you tightly control everything that goes into the registry and what your developers can access. You can run your own custom scans and ensure you are meeting any compliance or security requirements for your organization. And since it's a fork, you can pull from the vcpkg public registry anytime you want to get updates. You may also want to set up a registry for your own private libraries. You can organize these as you see fit and give your team the same user interface to install these libraries as they would be using for open source ones. Now, I mentioned earlier that vcpkg is build system agnostic. You can configure it with your preferred environment. With that said, vcpkg has some additional support for MS-Build and CMake projects that is worth calling out. In manifest mode, you can configure your project system to automatically run vcpkg so that it can restore any dependencies that are needed on the fly at build time. In MS-Build, this is done by setting some project properties. In CMake, this is done by pointing to the vcpkg CMake toolchain file. Another benefit of doing this configuration step is that these build systems will become aware of the locations where vcpkg is installing libraries, so you don't have to manually point to where your library headers and binaries will be located. Next, let's talk about IDE and editor support. As vcpkg has grown in popularity, it has been adopted by several different coding environments. The Visual Studio IDE actually ships with vcpkg if you choose to include C++ components during the installation process. But you can also use an external copy of vcpkg, which is necessary if you want to use classic mode and install libraries to a location of your choosing outside of your project and Visual Studio installation directory. vcpkg is also supported in Visual Studio Code. You will need to use an external copy of vcpkg and install the Microsoft C and C++ extension, and if you are a CMake user, we recommend also installing the CMake Tools extension. Lastly, the JetBrains CLine IDE also added vcpkg integration. You can find documentation about this experience on their website. Another vcpkg feature useful for professional development teams in particular is asset caching. Asset caching allows vcpkg to work in an offline build environment, which some organizations prefer for security reasons. It is also useful if you have continuity of business rules to comply with. It uses download mirrors to upload and restore assets like source code and build tools needed to install packages. And that's it. This video covered all the major features currently available in vcpkg. Keep in mind that vcpkg is an active open source project, and we are continuing to add to it over time. If you want to learn more, there are a few resources available. First, you can check out our website at vcpkg.io. Our documentation can be found at learn.microsoft.com/vcpkg. Lastly, our main GitHub repo can be found at github.com/microsoft/vcpkg.